Hello everyone, this is ML Naruto. Welcome to my channel. So today I'll be discussing about what is meant by a geometric mean. In the yesterday's video, I have already discussed about what is meant by a harmonic mean, right? So now in this video, I'll be discussing regarding geometric mean. So what is mean by geometric mean? For that, if you want to understand this particular thing, first of all, you need to look at the formula. So what is meant by the formula here? The what is the formula of this geometric mean? The formula of the geometric mean is nothing but square root of x, y. So here lies n, right? So what is this? What is this formula is actually explaining? So it is nothing but geometric mean is multiplying together all the n values, right? And then taking the nth root of the product. For example, if I have only two values, that is x and y, I need to multiply these two values, that is x into y, that is xy, right? And taking the nth root of this uh, values, right? If I have only two values, then I'll just multiply those two values and take the nth root of them. It is appropriate. This geometric mean is suitable in the situations where average rate of growth. This geometric mean is important where there is average rate of growth is considered, right? And when the rate at one point in time is dependent on the rate in another point in time, rate at one point time depends on rate in another point in time. So just don't worry about this topic. I'll explain with the help of a example so that you can understand it better. Okay. So for example, if I have a city, okay. So if I have a city and in this city has its own population, right? For example, from 1980 to 2000, this city has its population size from 1 million, right? Here it has 1 million population in 1980, and in 2000 it has become double, that is it has become 2 million, right? Now I want to know what was the population in the 1990. So here lies between some year, that is 1990. So I need to know what is the population when the year is 1990. What is the population? I want to know this, right? So if we use arithmetic means, so what would be the answer here? So the answer is nothing but simply we have two values, that is 1 and 2. So what we can do if we use arithmetic mean, arithmetic mean is the general mean we usually use, right? So the mean is nothing but sum of the all values divided by the total number of values. So what is the values here? 1 million, 2 million, right? So 1 plus 2 divided by 2, that is 3 by 2, right? So approximately 1.5 would be the 1.5 million would be the answer. Okay, so we can conclude that there lies 1.5 million population in 1990 year. This is only when we use this arithmetic mean, right? Arithmetic mean. But now, but now, however, here the rate of growth cannot be assumed uniform. For example, here, see here, in the 1980, the population is 1 million, right? So, and in the 2000, the population is 2 million. So you obviously think like in between the year, it has risen to some zero point 0.5 million. You usually think like that, but there may be a scenario like the rate of growth may not be uniform. For example, what I'm trying to say is here there lies 1980, here we have 2000, and if it is 1 million population here, then if here it is 2 million. In between, you usually think the population would be some 1.5 million. I mean, it has risen to from 1 to 1.5, it has risen to 0.5 million. You usually think like this. But no, there may be a scenario, there may be ups and downs in the population in the year 1990, right? So this is not the accurate metric to find the average rate of growth, right? So, why this is not the accurate metric? Why? Because see here, in the 1980 to 1990, there involves a 10-year period, right? And from the 1990 to 2000, there involves a 10-year period. So the rate of growth may not be uniform throughout this 20 year, right? Maybe it has risen in 1986, it has risen, and in 1989, it may have. I mean, it could be fallen, and in some other year it has risen, could have risen, and in the some other year, that is maybe 1995, it could have fallen. So likewise, the rate of growth may not be uniform. So I can say that arithmetic mean is not the exact metric to find out the average rate of growth. Then what is the exact metric for it? We can use the geometric mean. So that what happens is, see, I'll explain. So if you use the geometric mean here, we have two values, that is 1 million and another one is 2 million, right? If we use the geometric mean here, the square root of xy, here the nth root, right? So now what we can do is, how many terms are there? The first term, the second term, right? So we can use 2 in place of n, and this is the root for x into y. X is 1, y is 2. So it is having 2 to the power of 1 by 2. So the answer would be 1.414, right? So just observe here, when you calculate the arithmetic mean, it is 1.5 million, right? But now when you calculate the geometric mean, here it is exactly, I mean, this is the accurate, right? The geometric mean here is 1.414, which is smaller than the arithmetic mean, right? So it can be shown that for any data set, the harmonic mean is always the least of the three means, right? That is, harmonic mean will always be lesser than the three means. That is, uh, see here, the geometric mean. So this would be the scenario. The geometric mean will always be lesser than the harmonic mean, and this harmonic mean will always be lesser than the arithmetic mean. So this will be in an ascending order, right? So likewise, ascending order. In this order, the mean will usually increases. This would be the smallest value, and this would be the highest value, and in between these three means, there lies the average value, that is the middle value, that is for harmonic mean, right? So this is the thing here. So yeah, so it is, I think you have got some better clarity about geometric mean. When do we use the geometric mean? We usually use the geometric mean when there is average rate of growth concept in a particular problem, right? So rate of one point depends on the rate in another point in time, right? See here, the rate is actually depending upon this previous and the future point of time. We need to find out the middle one, right? So we need to look at the previous one, we need to look at the future one, so that in such scenarios we usually use the geometric mean. So that's all for this video. If you like my content, just share and like with your friends, like and share with your friends. Okay. So Yeah, that's all for this. Bye bye. Take care. Jai Hind.